Okay, so this problem we've started working on already. So we have already defined our variables. We said X is the number of chainsaws and Y is the number of wood chippers. And then we made a little chart with time. And we had 4 hours and 6 hours. So we said 4x plus 6y has to be less than or equal to 48. And then we had some information about profit, where for each chainsaw it's 120. So we wrote our objective function of 150x plus 220y. Okay, so now what we need to do is graph our inequality. So we're going to make a graph with labeling x and y. And many of these problems, the intercept method works great for finding points on the line for quick graphing. So when x is 0, y is 8. And when y is 0, x is 12. So I'm going to use units of 4 because that looks like it will work out easily for this problem. Oh, actually, I think I can just use 1 box as 1 unit, but I'm going to kind of ignore the boxes in the background. I'm just using them to help me stay kind of straight. So 1, 2, 3, 4, 5, 6, 7, 8. Here's my y-intercept. 1, 2. Here's my x-intercept. So here's my line. Oh, and now I need to make sure I have x is positive, x is greater than or equal to 0, and y is greater than or equal to 0, because I don't want to look at negative numbers of chainsaws. And then we said we need to graph the inequality. So let's test 0, 0. Say 4 times 0 plus 6 times 0 is definitely less than or equal to 48. So we need to shade the side where 0, 0 is. And then we want only positive x values and only positive y values. So you can see that this triangle is our feasible region. Okay, so that's write the inequalities, write the objective function. So this is the objective function. Graph the feasible region. Then the next step is going to be find points. So lucky for us, some mathematician proved that the highest value of the objective function and the lowest value of the objective function will happen at the corner points of the feasible region. So for this feasible region, the corner points are here, 0, 0. Up here, the y-intercept, and here, the x-intercept. So the y-intercept was 0, 8. The x-intercept was 2, 0, and the origin 0, 0. Okay, so I'm going to write those corner points, 0, 0, and then I start at 0, 0 if it's one of the corner points, and I go clockwise. And it's just so I don't miss a corner point, because sometimes there are a number of them. And then 2, 0. So those are my corner points. Now I want to evaluate the objective function, 150x plus 220y, at each of these points. So remember, evaluate means plug in. So it says plug in 0 plus 220 times 0 and get 0. So then I want to evaluate z at the point 0.8. So that's 150 times 0 plus 220 times 8. And that's going to be 1760. So this says if we make no chainsaws and 8 wood chippers, our profit will be $1,760. And then for the x-intercept, we'll have 150 times 2 plus 220 times 0, and I get 300. So clearly, the teacher made a mistake, and I'm going to go back and fix it. So I think it's more important for you to see how to notice and fix a mistake than to never make one. So that my x-intercept should have been 12. So I'm going to make a new graph here. 2, 4, 6, 8, 10, 12. Here's my x-intercept. 2, 4, 6, 8. Here's my y-intercept. And make my line. I still have this triangle as my feasible region and 3 corner points. The only thing that's different is this last corner point should be 12, 0. So it's 150 times 12. So that's going to be 1,800. So the smallest number you see for a z-value, this is going to be the minimum profit. Well, that's pretty obvious, right? That 0 is your minimum profit. If you don't do anything, you don't make any money. And then 1,800 is the biggest number you see. So the maximum profit $12 chainsaws and no wood chippers. Okay, so let's do one more example. I wanted you to objective function where you're trying to minimize rather than maximize. So this problem we've already done a lot of the groundwork. X equals pounds of deluxe coffee. Y equals pounds of regular coffee. And then we had x plus y was at least 50. X was at least 10. And then we said y needs to be a positive number also. And then we made our little chart and said for cost, have $6 for deluxe and $5 for regular. So then we can write our objective function as 6x plus 5y. And in this problem, the objective function z is representing cost. Okay, so let's graph our feasible region. Label your axes x and y. And let's use each box is 10. And we had x-intercept of 50 and a y-intercept of 50. And then when we tested 0, 0, we said we need to shade away from 0, 0. And then we have also the requirement that x be at least 10. So here's x is 10. And we want values of x that are greater than 10, so we find those to the right. And then we want positive y values. So we're going to find them x-axis. So here is our feasible region. So this feasible region only has 2 corner points. So I'm going to label them A and B. And to find A, you actually need to use some algebra because this is where x is 10 and x plus y is 50. So you need to plug in 10 for the x to see that at that point y is 40. So we talked about to find intersections of lines, you're solving systems of equations. So this is the point 10, 40. And then B is our x-intercept, so that one we can just write what it is. Okay, so here are my corner points. And I put them all together in a kind of a chart format. And then I'm going to evaluate z equals 6x plus 5y at each of these corner points. Okay, so I'm going to have z equals 6 times 10 plus 5 times 40, and that's 260. And then at the other corner point, I have 6 times 50 plus 5 times 0, and that's 300. Well, now that z is talking about cost, sorry, my page is jumping around. Z is talking about cost. So we want to minimize cost, so we want the smallest. So the smallest z number I see is 260. So the minimum cost is $260 when 10 pounds is blended with 40 pounds of regular coffee. Okay, so I'm going to make one more process. Okay, so you're going to define your variables, write inequalities. So inequalities help you graph the feasible region. Then you need to construct your objective function. What are you trying to maximize or minimize? Then you need to find the corner points. We actually did that in the previous section. Then you need to evaluate